Hello, welcome to another problem session. So today we are going to go back and do the JEE paper 2 from 2024 from India. So this is from an Indian test or contest, you want to say. All right, so this is a classic problem, except that it is a little bit more it's made interesting by adding some more detail of you don't really think about slits moving around. You think of slits as fixed, but you can actually uh, think of them as at any particular time it's fixed. Okay, so slits at time t is this, and it tells you the range in which slits can move around and what frequency. And this detail of time dependence is important for question 15. That's where the time part is, maximum speed. The part 14 is just for fixed slits. Okay, so we'll see how that plays out. The distance between the screen is given, and then so it's an interference pattern. You have to always be very careful how they count it. So we're counting in the question 14 and 15, both are for the 8th bright above point O. So the centralist part is always like this over here. So this is like, and there will be another bright spot. Let's call it 1. So this n equal to 0, this n equals to 1, and this is going to be 2, and so on and so forth. And somewhere, let's call this n. So when we're looking for n equals to 8, but I'm going to we should work out a general formula, and then we can just work with the 8 at the end. Okay. So the question is, nth part will be sometimes it's going to move in a range. Okay, the nth part is going to move in a range because of the d being moving up, and it sometimes shrinks to, you can see it's the distance between here to here. It gets larger by this or shrinks by this depending on the phase of sine wave, sine function. Okay, so it says two extreme positions. So clearly at some point in time the distance is smallest, and some time distance is largest. That probably corresponds to one corresponds to the highest place the n will be, and the lowest place the n will be. So this is the place the n will be, and the n will be all along this while it's moving, while this thing is expanding and shrinking. This, you can say this is being moved out. It's not talking about, and corresponding this thing is when it moves out, this thing is moved up so the slit doesn't widen. So there's a little bit of a technical thing there. Okay, as if how you're going to do this, but you shouldn't worry about that. So let's look at the condition, and then from there we will be able to garner the appropriate thing we should do to find this out. So let's look at this nth, and let's call this yn, and it's at some time t. Okay, and this is d. Let's call it b or a time t. I'm gonna change this d to a because we'll now have to take a derivative with respect to it. Okay, so let's make this a, and I'm going to call this a at some time t. So we're going to assume that this angle theta is small. Okay. And when drop that, this is the distance in the difference in distance between these two waves coming from here, waves coming from here, right? So this is the delta, and that's going to be, if this is A, this is going to be A. This theta, you probably know, is going to move all the way there to theta. So this will be A sine theta. This is 90 degrees. So it's like a triangle there, and this is A, and this is 90 degrees. This is theta, and this is the delta. And theta is different for different ends, so put it theta is n. Now distance is given in this distance and y, so let's call this L. So if this is theta n, so theta n will be yn over L if it was tangent. So we're going to assume a small angle, so that a tangent theta n, which is equal to a yn over L. Now if this was n times lambda, then it's going to be constructive over here. I mean, this distance delta n must be n times lambda. Here problem is n equals to 8, the way we've done this over here, right? So we can say yn, this question 14 is about yn in two extremes over there, yn for this versus yn of this. What's the range there? So yn will be equal to L over A times n lambda. So and A is the only thing that's changing with time. So these things are fixed. So n lambda L over A, which is a function of time. So this was changing. So clearly y will be maximum when A is minimum, and y will be minimum when A is maximum. So yn max minus yn min, and that's the question, what's the separation between these two extremes? That should equal n lambda L 1 over A min 1 over A max. So a little bit summarizing n lambda L, so A max minus A min divided by A min times A max. Okay, this is a now we have to do numerical value for this and write the answer in appropriate to two decimal places. That was the instruction earlier. Okay, so let's do decimal. Okay, so n is 8, so the answer will be 8, and we got to keep the units. So we have a lambda is 6,000 angstrom, and so that will be 600 nanometers, 10 to the minus 9 meter. Then you have L is 1 meter. And what is the maximum? What is the max for this? Max for this is when sine omega t is plus 1. So A max is 0.84. What's the A min? When sine omega t is minus 1. And so that would be 0.74. So 0.74 times 0.8 7684, and then the difference will be 0.08. But these are millimeter square. This millimeter will cancel out. So now we have to convert this into micrometers. So we can get rid of this this millimeter with this meter and have a factor of 10 to the power 3 in the process. And with this we can convert micrometers. That gives me 10 to the power minus 3 micrometer. So this cancels that. So rest is what we want. Okay, so I'm going to pause it and just going to do the calculator, give you the answer. Okay, so I got 601.5 micrometer. So this will be 50. So 601.50. This will go here. Okay, so that looks okay. To do 15, we want to figure out a maximum speed that this thing will move. So we already know where it will be. Just take a time derivative. That's going to give you the speed with this moving. So let's work out here. dyn dt is going to be, you can see, minus n lambda L over a square t dA dt. Now dA dt over here is it's in millimeter. So this is in millimeter. Let's call it. Let's say A equals to A0 plus delta sine omega t. So use this. So then will be minus n lambda L over a square t omega delta cosine omega t. Now we want the speed, so we want this, so that just kill all the minus signs, okay? And we want max. We want max of this. So basically we got n lambda omega delta coming from there, and we have a cosine omega t over a0 per delta sine omega t square so we need to find the maximum of this function. So we can call this f of t. how do you find maximum f of t? So find t that maximizes f of t. So you can do calculus, okay? And I'm just going to do the presentation, but I'm going to do what probably was intended in the test, okay? So the calculus one will be, you say df dt equal to 0, solve for t. Or you're basically going to solve for sine omega t or cosine omega t and cosine omega t. When you get those values, then you can plug in there, and then that should give the maximum. Now that's a mathematically sound way of doing it. There's a hand wavy way what they want you to do. So I'm going to do hand wavy way. Clearly, when numerator is largest and denominator is smallest, right? So you can see denominator is smallest when this is equal to -1. Then for that, cosine will be 0. That doesn't make sense, okay? So you go, that's actually not what you're going to find over here, you know? So one way is, say, when cosine omega t is 1 and when sine omega t is 0, then so you can do that. And actually I don't like it, but it seems like if you do that, then you get an answer which is reasonable, okay? But I would show you how to do that in just a minute, okay? And if you do that, it's just arbitrary and say t equal to 0, okay? What does t equal to 0 look like? T equal to 0 will be n lambda omega delta 1 over a0 plus delta square, a0 square, not delta, a0 square. And this turns out to be, you have to work out the numerical value for this. So numerically, you're going to have a much same as these kinds of numerical values. And so you are going to get, I got 24 micrometer per second. So that's one way, but let's do really a better way, which is find this by actually doing it, okay? Doing the calculus. All right, so I'm going to erase and then come back and try to present that. Okay, so let's do that derivative. So I did the derivative here, and we are supposed to set this equal to 0 to find the time where f will be maximum, take its maximum value. So over here you can set a0 plus delta sine omega t cube, and then you're going to get minus omega sine omega t, and this a0 plus delta sine omega t minus 2 delta omega cosine square omega t. So numerator has to be 0. So the numerator is expanding this. You can see the omega is in everything, so we can just get rid of omega. So omega here, two terms have both omega, just forget omega. So this is going to be minus a0 sine omega t minus delta sine square omega t. So 0 equals to sine square omega t minus 2 delta cosine square omega t. Now this will simply be 1 minus sine square omega t. So let x equal to sine omega t. So you get a 0 equals to minus a0x plus delta x square minus 2 delta minus okay, so this is minus here, minus 2 delta plus 2 delta x square. So you can see you can just divide this thing combines, so you have a delta x square minus a0x minus 2 delta equal to 0. So pause the video and carry out some of the steps, and a0 over delta, you have a 8.8 millimeter, 0.04 millimeter, that's 20, and so this will be 408. So x equal to half 20 plus minus square root of 408. You can just divide over there, so you have a 10 plus minus square root of you can say 4 goes in 102. So you got for the sine, this is for sine omega t. Then you can get for cosine omega t square root of 1 minus x squared. So take one of these values. One of them is negative, and it doesn't say why it can't be a negative time because this is going forever. So if you take the negative part, which is kind of a smaller value, so it's like a 10 minus square root of 102. So this is going to be minus like a 0.1 or something like that. So if you take this value, then cosine omega t will be square root of 1 minus 0.1 square, which is going to be 0.9, almost 0.99 or something. So for cosine you use that, and sine you can use minus 0.1 and plug in here, plug in over here to get a ft max, and then see what the answer comes out. It's going to be very close. Let me work that out and I'll be back. Okay, so I worked out this problem, and this algebra, all this, I worked out the numerical values, and it's very close to what we found previously. Okay, so this will be like a 24 as an answer. Okay, so it was a lot of justification for the trying to get the maximum, and that's okay. But I think the dirty method worked well, pretty well. All right. So I will be doing the next two problems in the coming days, so watch out for that. See you later. Bye.